Good morning, all. Let us discuss about the research paper named as an on breast cancer detection and application of machine learning algorithm on the Wisconsin Diagnostic Dataset. The author is Abhinan Fred M. Agrap. Okay, the paper focuses on improving the early detection of the breast cancer using the deep learning methods, and the methodologies are the researchers implemented a CNN model. It means the convolutional neural network uh, to analyze the breast cancer data set. And the data set that is used is the model was trained and evaluated using the Wisconsin breast cancer data set. Here we can see the data set. We are took this from Kaggle. This is how the data set looks like. This is how the data set looks like. We took it from Kaggle. Mm, It contains the 569 instances with the 30 numerical features derived from the digitalized images of fine needle aspirant FNA of breast masses, and the labels are benign 357 and malignant is 252. Next, let us discuss about uh, what are this research paper contains. The ML models. Machine learning models are evaluated in this research paper. They used the 6 ML algorithm. First one is GRU SVM. Here we can see that it is a hybrid model combining gated recurrent unit and a type of recurrent neural network RNN with a support vector machine. Innovatively applies RNN to tabular data and uses SVM as the final classifier instead of softmax. The test accuracy of this is 93.75% percentage. And next one they are used is linear regression, used for the classification, not traditionally used for the classification, but here a threshold is applied is just greater than or equal to zero point 0.5, and the test accuracy is 96.09 percentage. And they use the multi-layer perceptron, a deep feed-forward neural network with 3 hidden layers. Used ReLU activation and cross entropy loss. Best performance among all the models is approximately of 99.04 percentage of test accuracy. Next, we can see the nearest neighbor L1 and L2 norms. Uh, the non-parametric method using the geometric distance, and L1 accuracy is 93.57 percentage and L2 accuracy is 94.373 percentage. Next, we can see the softmax algorithm, softmax model, ML model, generalized of logistic regression for multi-class, used here in binary, used for cross entropy loss, and the accuracy was 97.65 percentage. And the last one is support vector machine SVM, used with a linear kernel and L2 loss for differentiability. Accuracy is about 96.09 percentage, and each model was evaluated based on the test accuracy and false positive rate, false negative rate, and true positive rate and true negative rate. Let us discuss about what is missing in this paper. The first one is there is a lack of cross validation. The study uses a single the 70 by 30 train test split, which can lead to biased results depending on how the data was splitted. This weaknesses the generalizability of the results. Next is no hyperparameter tuning. All models used manually assigned a hyperparameters without systematic tuning. This could result in suboptimal performance, especially for models like MLP and SVM. Next, limited dataset diversity. It means it only uses the WCD dataset is used here, and no experiments were done on other breast cancer dataset or the external validation sets, and no model explainability. And next is unclear handling of the class imbalance. It means the dataset has a 212 malignant and a 357 benign cases, a class imbalance. Through mild, could still skew matrices like accuracy. Next is no mention of balancing techniques. And the last is about there is no error analysis. There is no analysis of misclassification, means false positive or negative, and no insight into why or which kinds of samples the models struggle with.
Now we are going to explain our code implementation. In this, we are using in that paper there are no not done with the cross validation. We are here did that class cross validation for these models, and these are the libraries we are imported, and these are the data set we are taken. The dataset talks about mainly cell, the nuclear cell radius, texture, perimeter, area, smoothness. All the features are converted to mean. And then these are the 30 columns they are taken, and these are the samples, and we are plotted pair plot for visualization, and then we did the heat map visualization for the data set, and here we implemented the model logistic regression, SVM, and KNN MLP. For this we done the cross validation. uh, Here we imported some special library like pipeline, which tells about supports oversampling, undersampling steps, and SMOTE is that's random state is 42, and scalar standard scalar, and we use CLF model. um, Here we can see the training logistic regression. Best parameter CLFC is 0.1, and cross validation accuracy is 0.9772. And for training SVM, the cross validation accuracy is 0.9789, and for KNN cross validation accuracy is 0.9578, and then MLP is 0.9737. And we plotted the confusion matrix for SVM. Here we can see the 61 malignant cases correctly predicted as malignant, and that is a true positive, and uh, 3 malignant cases incorrectly predicted as benign. that is false negative. And then here we can see four benign cases incorrectly predicted as malignant, and that is a false positive. And then 103 benign cases correctly predicted as benign, and this is a true negative. And and we plotted the for decision tree for this. And lastly we can conclude that uh, training the models like precision, accuracy, recall, f1 f1 score support. Here we can see how the models are trained, the accuracy and precision. Class 0 is here 0 indicates that be benign, and 1 indicates malignant. The precision is 94 percentage predicted class zeros were correct. And then for f1 for recall 88%, it founds 88% of all accurate classes, class zeros. And then f1 score 91%, a good balance between precision and recall. And then overall accuracy is 94 percentage. Matrix training and testing is accuracy, for accuracy 94% training and testing is 97%. And then class 0 f1 is 91% for training and testing 96%. And then class 1 f1 is training is 95% and testing is 98%. Lastly we can conclude that in our paper we implemented MLP model. In original paper MLP model is 98.04 percentage. The testing and training is in that. In our paper we can implemented 99.3% with better generalization. SVM model is 96.09 percentage in original paper. In our paper 97 to 98 with tuned C and kernel. And logistic regression is 96.0109 percentage in original model. And then here we can implement that 97.5% with tuned regularization. For KNN model 94.7 percentage in original paper, and in our paper 96 to 97 with tuned K scaling and SMOTE. The difference is that lastly I can conclude that in original paper 70 30 split is taken for evaluating the model. In our paper 80-20 for evaluating the model for cross validation. And in our paper we can conclude that class imbalance SMOTE is not taken the in original paper. We handled it with correctly using SMOTE. And then here we can say that diagnostic insight is not good in that original paper. We in that paper that is a limited. In our paper the diagnostic insight is good, like a confusion matrix f1 feature importance, and then model flexibility is fixed in that paper. In our paper modular and extensible. That's it. Thank you.